All right, guys, so the three Waves labs today for you. We've got three different options here, Waves lab options 1, 2, and 3. I'm going to briefly go over all of them with you. Waves option 1 is a Glencoe lab. So remember that Glencoe labs are going to open as a flash lab, which means when you open the website, you need to then copy and paste it into an Internet Explorer site so that you can actually work the lab. Okay, so there are lots of different procedural things here for you guys on the left. You can read through them if you want, but really just kind of pay attention here to what I'm talking about so I can walk you through this and you guys can understand the intricacies of this lab. So you will be filling out this whole data table here. You've got plunger speed, size, amplitude, wavelength, and frequency. You'll have three different things for your slow plunger speed, small, medium, large, the same for medium, or slow, fast, and super fast. Okay, and then your three sizes here, small, medium, and large. Now, unfortunately, I cannot figure out how to turn the volume off on Internet Explorer, so you guys are going to have to kind of bear with me on that. It's annoying, but we'll get through it. So in order to kind of fill out your data table, you'll pick your plunger speed and your plunger size, and then we need to measure our amplitude, wavelength, and frequency. So in order to do that, we want to select our plungers here. So we've got slow and small. We want to make sure that your timer is at 0. And now when we start the plunger, you'll notice that this is going to go up and down and make some waves, but we definitely have to get a way to measure things. Okay, so we've got our plunger going up and down in the water right now. Now, if we click step, okay, if we click step, we can go a tenth of a second at a time. Okay, you can see it going up here, a tenth of a second at a time. And this is what's going to allow you to fill out your data table. So, from red to red is a wavelength. From this line to red is your amplitude. So we have to count some stuff, right? So if we want to go from here to here, well, your amplitude then would be 1. We want to count our wavelengths. Okay, so if we have just above 0 here, and we go to just about 16, so just about 1 to just about 16, well, that's going to be 15. Frequency, you're going to go for 1 full second and see how many full wavelengths go by. Okay, here's the end. So we're going to go to 7.3, and we want to see how many full wavelengths go. All right, so we were not quite a full wavelength, maybe 2/3, something like that, 0.4, that's close enough, right? Then, in order to get to your next plunger, you click stop plunger. It has to go through its full cycle. Okay, it will stop. Now, if you keep clicking that button, you're not going to make it go any faster. So it's got to go through a full wave cycle before it stops. Okay, then you'll go to medium, do the same thing, large, do the same thing. Then you'll click back to fast and go small, medium, large. Now, when you go to super fast, the super fast does not always have, I think it's super fast and large maybe, that doesn't have the little indicator measurement buttons. Okay, like I said, you just have to let the plunger go through its cycle there. So super fast and large does not have anything labeled. Okay, but by the time you get that far, you should have gone through this enough that you can kind of see what's going on with things. Okay, this is not a difficult lab, but it's definitely a procedurally based step-by-step type of thing. Okay, when you have all of your data filled out, you've got some analysis questions. How does plunger side affect amplitude? Okay, what are the correlations here between everything? Okay, so that is the first option for your labs. Your other options, your Waves lab option 2, you're looking at 2 different PhET labs. Okay, this one is on general waves, and then this one is on sound waves. Okay, when it says draw how this wave will change, I do want you to either draw it or you may describe it in words. That's completely fine. There is a pulse button here when it asks you what direction the wave actually moves in. Okay, you need to hit the pulse button. So you need to go step by step, just like we did for the last lab. When you're dealing with the sound waves one, you need to have your audio turned on your computer as well as in the simulation. Okay, you need to be able to hear what's going on with this lab. If you've never had a hearing test before, it's kind of a weird tone, but that is the tone that you're listening for. Okay, it will be very unmistakable when you hear it, but make sure that you've got your audio enabled on your computer as well, that it's checked on the simulation. Okay, you are going to actually, for this number 5, there's a little person in the lab, and you're actually going to click that person and drag them around and see how that changes the sound. Okay, so what you hear in the lab is actually what that person would be hearing, okay, if you were right next to that speaker. So it's a pretty cool little simulation, but make sure you're going step by step on it. The last lab here that is an option for you is a live lab. So the purpose of the lab here is for you to actually observe different wave types and control those different wave types. You will need a partner, so you and a partner will need a slinky. That Tammy can get you a slinky. It says to take out the slinky and sit on the floor. You can go on a lab table, you can go on a white table. You can certainly choose the floor if you want to, but wherever it's at so that you two are on a level surface. Okay? It says stretch the slinky out so that it's tight, but not too tight. You want that slinky to maybe be, about 3 foot long. That is plenty stretched out enough for this lab. Whenever you're shaking or moving things, the slinky itself should stay on the floor or on the lab table. So when you're holding it on the ground, shake one end from side to side. You're literally just going to take that slinky on the table and go from side to side with it so that you are creating one particular type of wave. It might be beneficial for you to have your intro to waves open so you can refer back to it when you're answering the questions for this slinky lab, okay? Because it's definitely, going right back to that intro and asking you specific questions. When it says make a diagram, I want a picture, okay? I do not want description here. I want a picture. So either draw one, paper pencil and upload it, or use Microsoft Draw and draw that slinky in there, okay? Other things here, so the analysis questions, there's only 3 of them, but you're taking a look at law of conservation of energy. We talked about that a little bit in the third standard. So kind of refer back to that standard if you need to, but that is your third option there for your labs, okay? You do need to do 2 of them, so upload them separately, and then you are good to go on that.